Hello viewers, welcome back to my channel. Hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. I have created several playlists depending on the problem categories, dynamic programming, sorting, searching, BFS, DFS and so on. Please go ahead and check them out. Also, I have uploaded the code for this problem to GitHub. You can get the link from the description below this video. Let's jump into today's problem. The problem is reveal cards in increasing order. The deck of cards, every card has unique integer. You can order the deck in any order you want. Initially, all the start face down. All cards start face down. So unrevealed in one deck. So you are not seeing those cards, right? So now you have the following steps repeatedly until all the cards are revealed. Take the top card of the deck, reveal it and take it out of the deck. So what we are doing is all the cards are facing down and you take the card, reveal it and take it out of the deck. If there are still cards in the deck, put the next top card into the back of the deck. That means we are putting that next card into the bottom of the deck. Still we are not seeing though, right? So we are not seeing the next top card and putting into the bottom of the deck. And if there are still cards, go back to step 1 and do the same thing. Take it out, reveal it, and the next top, take it out and put it to the bottom card. So like that. So what we are essentially doing is, first operation is take the top of the card, show it and take it out of the deck, and take the next top and put it into the bottom of the deck, like that. So we are doing that 2 steps, 1 and 2 repeatedly until there are some cards, otherwise we'll stop, right? So this is what the operations, there are essentially 2 operations that we are doing, right? Take one card and show it and take another card, put it to the bottom of the deck, like that, repeatedly. So now the task is return an ordering of the deck that would reveal the cards in increasing order. So basically whatever the cards that we are going to reveal, right, that is step 1, right? So you are taking from the top of the card and reveal it. So that revealing should be in the increasing order, right? So that's what it is going to be. So we need to come up with an algorithm to come up with deck order, so that all the cards that we are showing to or revealing are in the increasing order, right? So the first entry in the answer is considered to be the top of the deck. So you will have to give the answer in the same array fashion. So we are given with an array and we have to give back also an array. So whatever the number that is at the 0th index, right, that is what it is. The first entry in the answer is considered to be the top of the deck. So whatever it is there on the 0th index, that is the top of the deck, right? So let's go ahead and try to understand with an example, right? So we will get the example as this one, 17, 13, 11, 2, 3, 5 and 7, right? So now the output expected is this one. So out of all, if you look at the input, right, the lowest number, I mean the minimum number is 2, right? So as we have to increase, we have to reveal the numbers in the increasing order, right? The first number should be the lowest number possible, that we know, right? That is simple. But if the step 2 is missing, we could just easily put all the numbers in increasing order and we are done with it, right? But there is a step 2, right? That means we have to take the next top card and put into the bottom of the deck. So that means once you just have the order in sorted order, right, is not going to be sufficient, right? So we need to do something else also. So let's go ahead and look at and try to understand what the explanation given here is, right? So output is this, that's what it said, right? Input is this one. So whatever the order that we are given, it doesn't matter. Whatever the order that we are going to give as the output is the one which we want, because we want to reveal all the cards in increasing order. So let's try to work with the output, right, and see if it really follows the steps 1, 2, right? Steps 1, 2. So now, so 2, 13, 3, 11, 5, 17 and 7. This is the ordering, right? So as we know, the first entry is the top of the deck, 2. So we reveal it, right? We reveal it. 2 is the lowest number possible in that deck, right? We reveal it. Next top will be 13. What we are going to do? We are going to take that and put it to the bottom of the deck. So when the first index is the top of the deck, last index will be the bottom of the deck. So 13 will go back to 7. So after 7 we will put 13. So that is what it is, right? So after 7 we move it to the 13 card as after 7. So we moved. Now we reveal the third 3. The next top is 3, right? We reveal that and put 11 back. So that will become this one. So next reveal 5, put 17 back. Reveal 7, put 11 back, right? Reveal 13, so reveal 13, put, there is nothing to put actually. There is reveal 17. So likewise, we have to reveal. So these are all, the revealing is happening in the increasing order. So whatever the order that we came up here in the output is correct one. So now how to get this kind of ordering is the question, right? So what we are going to do is we are going to do exactly the opposite of these two steps. So that is the logic that I am going to use for coming up with an algorithm, right? So what we are essentially doing, we are taking the top of the card and revealing it, right, and putting the next top into the bottom of the deck. So first step, since we want to reveal them in the increasing order, right? So what I am going to do is take the input and sort it first, right? That is the first step. And the next step, once the deck is sorted, we are going to do the opposite of these two steps. So what we are doing, take the top of the card and reveal it, right? So instead of revealing, put it back, right? And since we are putting the top of the card to the bottom of the deck, right? So in this case, the reverse of that is take the bottom of the card and put as a top, right? So that is how we are going to do. So I have written down the steps onto the right hand side to see what we are going to actually do. We will work out through the example and then jump into the code. Okay. So we will, first step is we have to sort, right? We have to sort because we want to reveal in the increasing order. So the first thing we want to be as 2. So if you sort this, right, what will be the output? So let me put it right here. 2, 3, 5, 7, 11, 13, 17. So that is the sorted, right? Sorted output. So now we will work in the opposite direction of those two steps. So what we are doing in the step 2, put the next top card of the deck at the bottom of the deck, right? So next top card of the deck as the bottom of the deck. So the opposite of step 2 is put the bottom card as the top of the deck. So what we are going to do is 2, 3, 5, 7, 11, 13, 7, right? So now what is the bottom of the deck? 17. So make that as a top. So that is what the step 2 we are going to do. Put the bottom card as the top of the deck. So put 17 back into 2, right? So that's what we are going to do. Next, reveal top card and take it out of the deck. That's what is the step 1, right? So instead of taking out of the deck, what we are going to do is add it back to the deck, right? Add it back to the deck. So these are the opposites of step 1 and step 2, right? So now we'll work with opposites of step 1 and step 2. Finally, return whatever the answer that we got, right? So we work from the back of the deck. Once we sort the input, right? 2, 3, 5, 7, 11, 13 and 17. So we sorted it, and the step 2 is anyway we are going to work with the opposites of the step 1 and step 2 described in the problem, right? So let's go through the example 1 and see how we are going to do it. So we are going to work backwards of the deck, right? So now, so sorted is this one, right? So just to give you one more hint here, if there are only 2 cards, right? If there are only 2 cards or less, if there are only 2 cards or less in the deck, as long as we sort it, we are good. We don't need to do any other operations. Just sort it and give that as the output. Let's say how to understand that. If there is only 2 cards, right? 3 and 2. Let's say 3 and 2, right? So you sort it, 2 will become 3, right? So now if you give this as the output, right? You give this as the output. Let's say, check if it follows the steps in 1 and 2 in the description or not. So take the top card is 2, reveal it. So 2 is revealed, so 2 is revealed, 2 revealed, right? And if there are still cards in the deck, put next top card at the bottom. So there is only 1 card. So even if you put bottom or top, it doesn't matter, since there is only 1 card. So now then next reveal the next card, that is reveal 3, right? Reveal 3. So that's how. So 2 is revealed and 3 is revealed. So they are getting revealed in increasing order. So what does it mean is, as long as the number of cards in the deck are less than or equal to 2, just sort it and send it as the output. That's it. But if there are more than 2, then we have a workout to do, right? So in our example 1, we have more than 2, right? Let's do the workout. So the number of elements are how many here? 7, right? Since the index is 0 to 6, right? Number of elements is 0 to number of elements is 7. Index is from 0 to 6. So now I have I is equal to 6 as initialization, right? So I pick the 6th index and put into a list, right? Put into a list, and then decrement I, that is I is equal to 5 now. And now add 5 into the top of the deck, right? Whatever it is there at the index 5, add that into the top of the deck. We have added, right? And decrement I is equal to 4. So now what we are going to do is the opposite of the step 2. Put the bottom card as the top of the deck, right? Put the bottom card as the top of the deck. So what is the bottom card here? 17. So put as the top of the deck. So now this is the array. So now put bottom card as top of the deck. What it will become? 17 and 13, right? And I is equal to 4. What is the fourth one is 11. So put it, right? Now decrement I. Now again put bottom card as the top of the deck. So 11, 17, 13 will become 13, 11, 17. So now after that, what is I is equal to? I is equal to 3. Put I is equal to 3 is 7. Put it the top, right? And next put the bottom card as the top of the deck. What is the bottom? 17. Put 17 back. So 17, 7, 13, 11. So what is I? I is equal to 2. So what is 2? At the location 2, it is 5. Put it at the top, and now put the bottom card as the top. So 11 will come top. 11, 5, 17, 7, 13, 11. So after that, decrement, right? I is equal to 1. So I is equal to 1 is 3. So put 3 under the top of the deck. So 3, 11, 5, 17, 7, 3. So I is equal to 0 it will become. And after that, put the bottom of the deck to the top. So 13 will come to front. So 13, 3, 11, 5, 17, 7. So now I is equal to 0. Put 2 is at the top. So after we put it back, right? This is when we end, since I is equal to 0 came, right? Now after that we decrement I. So I will be minus 1. So as long as I is greater than 0, we are going to do this operation, right? So this is the final ordering. So if you compare this ordering with this, right, it is exactly same. So it is a little bit confusing how we are doing, but just think in these lines, right? Whatever the operations that we are doing in step 1 and step 2, come up with an opposite. Just like I said here, put bottom card as the top of the deck. The opposite of that is, right? So what we are doing is put next top card as deck at the bottom of the deck. We are taking in this step, take top of the card to bottom of the deck, right? The opposite is take bottom of the card and make it as top. So that is what I am doing. Put bottom card as the top of the deck. That's it. So just try to work it in a reverse order of the steps 1 and 2, and we will come up with the order that we want. Let's go ahead and look at the code for this. It's exactly following the steps that I have opposite here, right? So deck revealed, increasing. So we are passed with the deck. The first thing that we are going to do is sort the deck, right? Since we want the numbers to be in revealing in increasing order. And then I am creating a list. This will be a answer list that I am going to return. Get the deck length. If the deck's length is less than or equal to 2, as I said, we just return whatever the sorted deck. We don't have to do anything else. Once it is sorted, it is going to reveal in the increasing order anyway, as long as it is the number of elements in less than or equal to 2. So now, if it is more than 2, so since we are getting the length here, we want to actually move to the index, right? The last index. So if there are 7 elements, the last index is at 6th, right? So that's why we are decrementing n to reach to the last index. So now we reach to the last index. Whatever we are at the last index, we are adding that to the deck, right? So we are adding that to the deck. So as we said, if there are only 2 elements, we are just going to increment. Sorry, we are just going to return, right? So the next element also we will have to add to the first position in the deck. So you decrement and add the next element in the deck to 0. So n is keep decrementing here. So n value is not constant, right? So we decremented n and added at the first position in the list and decremented n. So now we are going to enter the while loop. So this, by now we have added 2 elements into the list. That's it. By now we have added 2 elements into the list. So if it makes sense for you, you could remove these 2, right? You could remove these 2 statements. If n is less than or equal to 2, return the deck. Anyway, once you decrement n, when your number of elements are 2, it is not going to enter this while loop anyway, and we are going to return. So this is a redundant per se, but since we talked about when there is less than number of elements are less than or equal to 2, we are going to return the deck as is. That's why I kept it like that. Okay. So this is same as these 2 steps. There is no difference. This is a redundant step. You can remove from the code if you want. Okay. So now we are going to enter in the while loop. So once we are entering the while loop, that means the number of elements in the given deck are more than 2. So what we are going to do is take the bottom, remove it from the bottom and insert at the top. So 0 is top, right? Insert at top, right? So now after inserting at the top, insert new card at the top from the deck, right? So 2 operations. What we are doing is insert the bottom deck at the top and insert new card at the top, and after that we are decrementing n. So we will continue this until n is greater than or equal to 0. Once n becomes negative, right, we are going to return the list back by converting into an array, because the output is array, right? So that's how we are going to proceed, right? Let's go ahead and look at the time complexity and space complexity for this algorithm, right? Time is how much time we are needing here. So we are doing the sort. So typical sort is order of n log n, assuming that length of the deck is n. So length of deck is equal to n, right? So in that case, the sort will take order of n log n, right? Plus we are going through that deck n times, right? So since n is greater than or equal to 0, this while loop is executing almost n times, even though it will be n minus 2 here, right? So it will be all n times, right? So the total complexity for this will be order of n plus order of n log n. So totally what we could say is order of n log n, the time complexity for this algorithm. The space. So how much space we are using? The space we are using is we since we have to return another array, right, which is equal to the length of the deck. So we have to use the space which is also equal to order of the length of the deck. So the space complexity for this algorithm is also order of n, right? So the time complexity is order of n log n and space complexity is order of n. So hope that clarified any questions you have. If you still have any questions, please post them in the comment section below this video. I will get back to you as soon as I can. I have posted this code to the GitHub repository. You can find the link in the description below this video. If you haven't subscribed to my channel, please go ahead and subscribe and also share among your friends. Please click on the bell icon so that you will be notified about all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe. Goodbye.